All right, IB AI SL2. Today we're going to start talking about integration, which today really just focuses on area underneath certain graphs. So the first graph we're going to look at is a velocity versus time graph. This is a graph representing an object that travels at a constant velocity for 8 kilometers per hour for 4 hours. You can see that here, that the velocity is at 8 for the first 4 hours. Then for 2 hours, the velocity decreases until it reaches 0. So that's what's happening right here. We need to figure out what distance did the object travel during the entire journey. So the distance that the object traveled is going to be essentially the area underneath this curve. Because if you travel at 8 kilometers per hour for 4 hours, the distance that you traveled is 8 times 4, which is 32. So we're trying to find all of this area here underneath the curve. To be able to find it, we're basically going to split it into 2 different sections. We're going to take the first 4 hours as a rectangle, and then the last 2 hours as a triangle. So the distance traveled is going to be the area under the curve. To find the area, we're going to do the rectangle plus the triangle. So the rectangle right here is 4 by 8. So this is area is 4 times 8. But then we have to add on the area of the triangle, and the triangle has a base of 2 and a height of 8 here. So this is 2 and this is 8. So a triangle is 1/2 base times height. When you add that all together, I believe this is 32 plus 8, which is 40. So area equals 32 plus 8, so area is equal to 40. Now, what does that 40 represent? That's 40 kilometers that the object traveled. In 6 hours. That's it for that problem. Next problem. For this velocity time graph, find the distance traveled. Now with this one, they didn't give us accurate tick marks, so we have to start figuring out things about the graph given this model right here, -5t plus 10. So if you put a 0 in for t, you get a 10 out of that function. That means that this is 0, 10. Then if you set the equation equal to 0 to figure out what this point is right here, you get 0 equals -5t plus 10. Subtract 10 from both sides, divide by -5, and we get 2. So that means this is 2, 0. To find the distance traveled, we're just going to find the area underneath the curve. So we're just going to find this shaded area here, which once again is another right triangle. We just figured out that the base is 2. So this side is 2, and then we figured out that this side is 10. So the area is going to be 1/2 base times height, just using that triangle area formula. So the area here is 10. Now, what did we just find? It's not just that the area is like 10 units squared. Because this is velocity, if you find the area under the velocity, that is the total distance traveled. So 10 kilometers traveled in, no, meters, not kilometers. I was like, oh my gosh, this thing is moving fast. 10 meters traveled in 2 seconds. That's it for that problem. This next one, we're going to find the area under the graph again, but this one's a little bit trickier because we don't know what point this is at. To be able to figure out what that point is, because we're going to split this up into the area of a triangle and the area of a rectangle and add them together, but we need to know all the numbers involved. So to figure out where these two things intersect, like I want to figure out this point right here, we need to set the two equal to each other. So y equals 3 and y equals 1.5x. So you say 3 is equal to 1.5x. Then if you divide both sides by 1.5, you get that a is equal to 2. Oh, sorry, that should be a, because x is equal to 2. A. It doesn't matter. That means that coordinate is 2 comma something, but we don't know the other. Oh, well, we do know the other part because this is y is equal to 3, so that lines up with a y value of 3, so that's 2 comma 3. Then this point right here is 5 comma 3, and that means that this distance right here is 2, this distance here is 3, from x equals 2 to x equals 5, that means this is a distance of 3, and this is a height of 3. So area equals the triangle plus the rectangle. So the area is 1/2 base times height plus the area of a rectangle, which is just length times width, or base times height, however you want to think of that. So this is 3 plus 9, which is 12 units squared. Yeah, that's it. Now, you guys, we're not always going to deal with shapes that are like triangles and rectangles. There's going to become a certain point where you're trying to find the area underneath a curve. So the area underneath the curve is right here. So there's lots of ways to like kind of split that up, and like, you know, the book shows this whole investigation of, you know, if you make like little rectangles underneath it and like try to estimate like how much it is, and then you get a pretty good estimation of the area, but then there's like these little parts that are left out, like these little triangles. So then you say, okay, well, what if I make them smaller? Like, what if I do all these little rectangles, and then you go smaller and smaller and smaller? Basically, if you go like infinitely smaller with all those rectangles, you're finding, gosh, what are we calling it? A definite integral. So let's read through this. When f is a non-negative function between a and b, then this fancy notation right here gives the area under the curve from a to b. So that fancy notation, how you read that, is the definite integral between a and b. The top part, the number a, is called the bottom part is called the lower limit. So this is the low limit. And the top part is called the upper limit. So this is your upper limit. Now, eventually I'm going to show you guys kind of some calculator techniques to be able to find these, the area under like a certain curve. But our last couple examples today are just going to be another straight situation where you can use certain formulas. So they gave us a function, negative x plus 6. And then we want to write the definite integral that gives you the area of the shaded region. Well, this is 1 and this is 4. So that would be 1 to 4 of negative x plus 6 dx. The dx part, don't worry about too much about what it represents. It just always goes on the end of a definite integral. Now we're going to find the value of that definite integral. Because we don't know technically like how to do this with algebra and stuff yet, we're just going to take this shape as a trapezoid. Now this trapezoid has like a base of 2 and a base of 5, and then a height of 3. You kind of have to turn it on its side to look at it like a proper trapezoid. So the trapezoid area formula is 1/2 base 1 plus base 2, and this is from your formula packet, times the height. So this is 1/2, base 1 is 2, base 2 is 5, and the height is 3, and this whole thing is 10.5. So what that means is the integral from 1 to 4 of negative x plus 6 dx is equal to 10.5, because the integral is just the area underneath the curve. Last one. For the definite integral from negative 1 to 3 of x plus 4 dx, sketch the graph and shade the region of the integral. Well, first, we're integrating the function f of x is equal to x plus 4. So if you feed in a negative 1, you get out a 3. So at negative 1, it goes up to 3. So this is the point, negative 1, 3. Then if you feed in a 3 to that function, you get out a 7. So that means that 3, 1, 2, 3, 4, 5, 6, 7. So here is our definite integral, and we are going to shade underneath it. So we are going to find the value of the integral using an area formula. Okay, so this is 3, 7. So that means that this side right here is a side of 3. This is a side of 7. And then from negative 1 all the way to 3, that means this whole side is a side of 4. This is another trapezoid formula where you can do 1/2 base 1 plus base 2. So the area from negative 1 to 3 of x plus 4 dx is equal to 1/2 base 1 plus base 2 times a height of 4. And when you crunch that all out, you get 20. So that is your answer. Okay, you guys, your homeworks are mostly just like nice shapes and interpreting integration and stuff. Next class, we'll get into some actual curves and how you do that using a graphing calculator. Good luck.